Hey everyone, today I want to go over what we learned in Module 3 when we discussed number theory and integers. I'm going to go over just a few of the questions that we ran into while learning this module. First, when you take a look at my screen, you'll see the divisibility rules. Each number has its own rules. For instance, if you're looking at 2, you'd have to make sure that the last digit of each number, like 684, is an even number. So this one would be divisible by 2, 2064 would be divisible by 2, but 51,051 would not, because 1 is not an even number. You'd go through and look at each number, and like I said, each number has its own rule. 3, you'd have to add all of the numbers together, and if the sum of that number is divisible by 3, then that number is also divisible by 3. 4, you would add the last 2 digits of the number. If that sum is divisible by 4, then it's also divisible by 4. 5 and 10 are the easiest ones for me because 5, the number has to end in a 0 or a 5 in order to be divisible by 5, and 10, the number has to be a 0 for it to even be divisible. So, other than the divisibility rule, we also learned about remainders. So, with the remainders, you would take this problem. It starts out as 416 plus 7,490 plus 69,844 equals 112,790. But actually, that's the wrong answer. So first you would need to add all of the numbers together and get the correct answer, which once they're added together, the answer is actually 77,750. So you would take the given answer and add all those digits up. So you do 1 plus 1 plus 2 plus 7 plus 9 plus 0 equals 20. And you would divide that by 9. Well, 9 times 2 is 18. So you wouldn't divide that by 9. I'm sorry. You see what goes into 20. So 9 times 2 is 18. Well, 20 minus 18 is 2, so you would have a remainder of 2. And you would do that also for the correct answer. Once you find both remainders of those numbers, you go back to the original problem, and you're going to add those digits in each number together and also get those remainders. So for instance, 4 plus 1 plus 6 equals 11 with a remainder of 2. 7 plus 4 plus 9 plus 0 equals 20 with a remainder of 2. And 6 plus 9 plus 8 plus 4 plus 4 equals 31, which would then have a remainder of 4. Make sure that you know what sign you are working with at the beginning of your problem, because that sign is going to take place right here in this section. You're going to take these remainders, and since this one started out with addition, you're going to add them all together. So 2 plus 2 plus 4 equals 8. And you would see how many times 9 would go into 8. Well, since 9 doesn't go into 8, your remainder is 8. As long as the correct answer is remainder and your remainder match, then you're correct. And this can work with all different types of numbers. Small, large. You can do it with subtraction, like over here in this problem. Just remember, once you get to these last remainders, you do 8 minus 2 instead of adding to get your remainder. And also the same with multiplication. You get your remainders 4 and 8, multiply those, and then you'll find your remainder after that. Now, working with colored rods and trains. When you're looking at colored rods and trains and trying to figure out which rods would work, you're actually looking for the factors in the problem. So for a 9 rod, it would be your factors are 1, 3, and 9, because 1 times 9 equals 9, and 3 times 3 equals 9. So you can see where it's drawn right here, 1 centimeter blocks times 9, and 9 centimeter block times 1. And 3 by 3 by 3 equals 9. You can continue to do that with any number to find the train or just the rods to make that problem. So with an 18 train, you have a 10 centimeter rod and an 8 centimeter rod put together. And so you'd have to figure out what factors would make 18. So it'd be 1 and 18, 2 and 9, 3 and 6. That can be shown with 10 1 centimeter blocks and 8 1 centimeter blocks. That makes 18. You have 2 centimeter blocks times 9 equals 18. 3 centimeter blocks times 6 equals 18. 6 centimeter blocks times 3 equals 18. And 9 centimeter blocks times 2 equals 18. So the representations are pretty similar, and they're easy to read once you understand what you're looking at when it comes to a rod and a train. Just know that the greatest common denominator of two numbers, say G and H, is the length of the longest train or rod that will measure both the G train and the H train. Now we're going to move to the lowest or the least common multiple. You have three numbers here, 48, 25, and 65. So if you make a chart or a table and put 48, 25, and 65 at the very top, then you're going to start factoring it out. I always start with the lowest prime number, which is 2. Well, 2 goes into 48 24 times, but 2 doesn't go into 25 or 65, so you'll just continue to bring those down until you're done with your 2. Well, 2 goes into 24 12 times, and again, bring that 25 and 65 down. Well, now 12 can actually go in, 3 can go into 12, so instead of doing 2 into 6, because you're still going to get a 3, I just went up and did a 3 into 12. Well, you get 4. Well, 3 also doesn't go into 25 or 65. So you continue to bring those down. Well, now 2 goes into 4 2 times. And then, so you're left with 2 as a prime number. So what would go into 25 and 65 as a prime number? So you'd go with 5. 5 goes into 25 5 times, and it goes into 65 13 times. So now you've got your problem to the prime numbers. So then you take a look and you count how many times your prime numbers are on here. So for instance, your 2s, you have 1, 2, 3, and 4. So you would have 2 to the 4th power times, you only have 3 once, so 3 to the 1st power, times 5 is on here twice, so 5 squared, and then you'd multiply it also by 13 because that's still your last prime number. This works with any number of problems. You can have 3, you can have 4, they can be in the hundreds, they can actually be in the thousands. And as long as you slowly make your way through it, your prime numbers will always factor out into it. Just remember to use the prime factorization, and this will give you the prime power form of the least common multiple. Now, another way of doing the least common multiple, say for instance, this next question It actually was a representation of a gear. It had two sizes of gears. One was 48 and one was 84. Well, in order to find the least common multiple for this number, I use the factor tree. So much easier for me to understand. So we first take 48. Well, I know that 2 goes into 48 24 times. The 2 goes into 24 12 times. 2 also goes into 12 6 times, and then 2 goes into 6 3 times. So you have 4 2s, 1, 2, 3, 4. So you'd write it 2 to the 4th power, and 1 3. And 84, you have 2 goes into 84 42 times, 2 goes into 42 21 times, and then the prime numbers for 21 are 3 and 7. So you'd have 2 squared times 3 to the 1st power times 7 to the 1st power. So when you write this equation, you have 2 to the 4th power times 3 and times 7, which multiplied together, you're going to get 336. Now we're trying to figure out how many rotations the small gear has to go in order to get back in the same spot. So you would take that 336 and you would divide it by that small gear, which is 48, which you get 7. So the small gear will have to make 7 rotations before it reaches back to the same position it began. Now last, we're going to look at magic boxes. Here it gives you a list of numbers, well, magic squares. So first you would have to find what this magic sum is. So you would take all of what they give you. In this problem, it's -7 plus -6 plus -5 plus -4 plus -3 plus -2 plus -1 plus 0 plus 1. Add all of those up and you get -27. Well, this magic square is a 3 by 3. So you do 3x equals -27. And now you're going to divide that 3 into that -27. You get -9. So the sum that you're looking for is -9. That's going to be the sum to each row, each column, and also diagonally. Now this one started off and it gave you the 0 in this box and the 1 in this one. Well, then it's pretty much just a guess and check until you fill the squares and they all make a -9. So you have 0 plus -7 plus -2 equals -9. -5 plus -3 plus -1 equals -9. -4 plus 1 plus -6 equals -9. And then you'd also go to this side, -5 plus -4 is -9. -7 plus -3 plus 1 equals -9. And -2 plus -1 plus -6 equals -9. And don't forget your diagonals, they also have to equal -9. But once you figure out what those answers are, your magic square is complete and you can continue. I hope that I gave you a little bit more intel to what problems we ran into this semester or this module. And I hope that you understand just a little bit more of how to do them, where integers play, prime factorization, all of that. Well, all right. Have a good day. Thank you.